Alright, so I'll write up these solutions really quick. This worksheet's slightly modified from the one I gave out in class. This one is a little bit simplified in terms of ignoring the effect of friction and air drag and such. So, battery-powered car and diagram below is moving up a hill at a constant speed. Ignore the effect of friction and drag on the car. So, it's going uphill, right? We always think about the lowest point in the motion being our zero height. So that's h equals 0. As it goes up, it gets higher and higher, right? So h is increasing. Its speed is constant. So I guess since the speed is constant, I know the kinetic energy has to be constant. So the kinetic energy in all three positions has to be the same. I'm just going to say it's 2 bars for now. 2 units of kinetic energy. And then if we have to, we'll go back and add more, right? So I'll put a line there in case we have to add more later on. It's really a good idea to do these in pencil in case you have to modify them. So kinetic energy is constant. Now the height is increasing, right? So starts off at no height, so no potential energy, gravitational potential energy. It gets higher, so it's got to be bigger and bigger. So I guess I'll make this 1 unit of PEG at location 2. It's gone up a little higher, right? At location 3, it's gone up even higher, so I guess I better make that 2 units of PEG. No spring. Oh, yeah, no spring. So nothing to do there with spring energy. If there's no spring, you don't include it. E other. No internal because it says ignore effect of friction and air drag. So internal I don't need to worry about. Internal is the same as thermal, right? That's the same as thermal. Or internal we call that. The problem here is our total amount of energy is increasing, right? We go from 2 units of energy to 3 total units to 4 total units. Where's it coming from? Well, it's coming from the battery. Battery/work. Alright? It's coming from the battery. So we're going to have to call that our E other. And how much do I need? Well, I guess I would do 2. Maybe I would do 3 because, you know, it's not stopping here. It looks like it's going to keep moving, so we must still have some energy left over. So if I did 3 E others to start off, right, then it will have to have gone down here. Oops. Let's do that. It'll have to be 2 E others here, and then maybe we have 1 E other left over here in order to keep moving. So 3, 2, 1. So it shows the other energy has to decrease, and it decreases by the amount the gravitational is going up. So the gasoline engine, it's in your car, it's going into keeping your car moving at its speed, and when you have to go up a hill, it really uses a lot more energy, a lot more gas. Alright, this one here, it's asking about the starting and ending position. So there's no arrow next to location 1 or 2, so the V is 0. The V is 0 at here and here, 1 and 2. So that means there's no kinetic energy. So it says you're dropping from some height, right? Ball goes down, hits the ground, it bounces up. It doesn't go as high as it started, right? So let's say initially I wanted to say it's all gravitational potential energy, so I go for the gusto and I say it's 4 units of gravitational potential energy. Well, that means then, as it falls, that's going to go down. So the gravitational energy is going to decrease as it falls. When it gets right down to the ground, it's going to be no gravitational energy. It's going to be all kinetic energy. Then it bounces. And it doesn't go as high. It only goes about 2/3 of the way up. So I'm just going to make it like 3 units of PEG. Not as much. Not nearly as much. Right? Well, where did it go? Well, there's no kinetic energy at location 2. There's no spring energy. E other, I don't think I need. There's no other source of energy in this problem other than gravity. It must have gone into internal energy. In fact, it got its internal energy here. right? You could think about the bar graph for this location, right? What would be the bar graph for this location? Well, PEG would probably be 3. It'd have to be the same as this one. And the KE would be 1. KE would be 1 unit. And then, how about right here? Well, the internal energy would have to include, the PEG would have to be like 1 unit. KE would have to be like 2 units. So that's a good one. You have to factor in internal energy in this one because, you know, there's nowhere else it could have gone. Alright, this one here, car is launched by a compressed spring. It goes down a hill. Ignore friction and air drag acting on the car as it moves. So, spring energy. Oh, I don't know, we got a spring launching it. Let's say it's 3 units of spring potential energy stored up in there. Alright, so the spring launches it. Well, look, here's its lowest point in its motion. It's 0 height, right? H equals 0. It started off above that, right? It started off with gravitational potential energy relative to where it ends up. So, I guess I'm going to say that it started off with, oh, I don't know. Well, it's going to go down, it's going to be constant, it's going to go down, get cut in half, and then go down to 0. So I guess I'll say it started with 2 units of gravitational energy. Alright, at location 1. So we've got 5 total units of energy here at location 1. Spring potential and gravitational potential energy. So that spring energy, when we launch it, right, when it gets to 2, it's still at the same height, so it's got to have the same gravitational energy. The spring energy has now been lost. It's all been converted into kinetic. Alright, so that spring energy gets converted right into kinetic. I don't need any E other here yet. I don't see any reason for that yet. Internal, it says ignore friction and air drag, so I don't need to worry about that. That's it, and this counts. Gravitational is the same. The spring got converted into kinetic energy to get it going. And now it starts going downhill. So it's got this big kinetic energy. And now it starts to lose gravitational energy. So it loses 1 unit of gravitational energy. Right? It's cut in half. Well, where'd it go? It must have went into kinetic. So, and now I have 4 units of kinetic energy. Right? Because this has gone down, it's gone up. And then it gets to the bottom, it's all kinetic. There's no more gravitational energy at all. So, unfortunately, I've gone off the graph here. I've gone off the chart. It's got to be 5 units of kinetic energy to make this work. Right? It's all kinetic down here. 5 units worth. Alright, the next one, scatter descends at a constant velocity. You may not ignore friction and air drag. So you may not ignore friction and air drag. Because without friction or air drag, a parachute doesn't do anything. Without air drag, a parachutist cannot fall at a constant velocity. So, here's our lowest height. PEG equals 0 at the bottom. H equals 0, so there's no gravitational energy down here. So we start off with a big gravitational energy, right? So let's say the gravitational energy was 4 units. Started high up off the ground. Well, at location 2, it would have to be cut in half. It's going to be 0 by the time we get down to location 3. So location 2, it will have to be cut in half, the gravitational energy. Now the kinetic energy, I don't know, maybe that's 2 units. No spring, so I can skip that bar. Kinetic energy, it's constant. Let's say it's 2 units of kinetic energy. 1, 2. Well, then it's also going to be 2 units here because it's the same speed. It's got to be 2 units there. It's all the same speed. So we see we have an issue, right? We started with 6 units of energy to start off at that location 1. Now we only have 4. Then we only have 2. So what's happening here is as it falls, the internal energy is building up. Right? So here, internal energy must be 2 to make this a count, right? Because we need 6 total units. Then over here, the internal energy must be 4 to make it a count. So we have 6 total units. Alright, so that's energy bar graphs Hopefully everything will go okay.